Hi everyone and welcome to my OSCP technical guide. In this episode we will continue my series on OSCP, and in particular we will discuss about the chapter on using existing exploits, which is a key technique you must master if you want to obtain the OSCP certification. And this is going to be the 5th episode on the material, on the technical material. Previously we also discussed the web, Linux, Windows, password attacks, and now in this video using existing exploits. In future videos we will also discuss about these things, which is port forwarding, client-side attacks, and Active Directory and report writing. So I hope the video is interesting. If you have any feedback, please leave it in the comments. If you want to show some support, please subscribe to the channel or just leave any comment, and that's it. I hope the video is enjoyable. So we can start our discussion about the technique on using existing exploits by observing that when it comes to OSCP and the final OSCP exam, we can classify the vulnerabilities we need to use in order to exploit the targets into two main classes. Those that we can manually exploit on our own, and those for which we need an external and already written exploits. This means is that anytime you find something that must be exploitable, like a vulnerability, a weaknesses in the system, that you need to use an exploit in order to go forward, then you can find yourself in these two areas. Those that you can just exploit on your own with simple payloads, and those for which you need an already written exploits. And in OSCP, the exploits you typically will have to write on your own are really simple. This means that you can sort of like abuse this knowledge or just use strategically this knowledge, in the sense that you find yourself a vulnerability, you try to exploit with simple payloads and it does not work, then it probably means you need to find an already existing exploits, maybe a CVE, maybe something on the GitHub, on ExploitDB and things like that. So when it comes to vulnerabilities of the first kind, typically you will find simple web vulnerabilities like SQL injections that allows you maybe to, obtain remote code execution or just leak information, maybe a union select, or a local file inclusion, an LFI, which allows you to read the private SSH key of a user within the machine. So like what I mean is that typically the vulnerabilities we have to exploit completely on our own are simple payloads. And in this matter, OSCP is actually not too difficult. It might seem weird because everyone is saying that OSCP is super hard, but that's not the case. OSCP is actually pretty entry level when it comes to basic payloads. Most of the time, the hardest part is in to understand the vulnerabilities. Once you understand them, to exploit them is pretty straightforward. The payloads here are simple in the sense that they are standalone and atomic payloads. And what do I mean with standalone and atomic? Typically, it means that the vulnerability can be exploited directly. So like I have a form, an HTML form, and I send an SQL injection and I immediately get my answer if I'm able to exploit it. Or like a local file inclusion, I give the path to the file in the operating system and the application returns me back the file. So stuff like that. At most, you will find exploits which require 1 to 2 steps. So maybe with one vulnerability, you set up a file that you then use with another vulnerability. But that's really the most complex thing you can ever find in OSCP. Once you find the right one, the right vulnerability and how to exploit it, you're good to go. No need to write complex logic to exploit these vulnerabilities. All can be done manually, or at most with the help of basic tools such as Burp Suite Community Edition. And you can use Burp Suite, but only the Community Edition. They don't want you to use the Pro Edition because with the Pro Edition you can also manually exploit the vulnerabilities, which they don't want you to do. And so when it comes to the first class of vulnerabilities, there's really not that much to say, because as I said, they are typically simple payloads. Either you know the basic vulnerability and how to exploit it, or you don't. And if you don't, you need to go study it. And if you don't even know what are the main vulnerabilities, go check out my videos on the web part of OSCP. the OSCP technical guide related to the web content. Now, when it comes to the other class of vulnerabilities, things get a little bit harder. The other class of vulnerabilities instead is a different story. These vulnerabilities are not always trivial to exploit, and they typically require to be scripted in Python or some other scripting languages. So here we are talking about vulnerabilities which could take multiple steps to be exploited. Like maybe you have a CMS on the web, sort of like a sort of WordPress clone, that you need to send various requests before you actually trigger the vulnerability. Or maybe you need to send a request, extract specific data, and then use that data to do the actual attack. So something that has to be scripted. And typically, when you find something scripted, either is an old exploit, which could be written in like Ruby or Perl, or is a more recent exploit which is written in Python. And honestly, the most exploits I found were written in Python, which means that in order to actually understand the exploits you're using, even if you did not write them, you still need to know how to read the Python code. Luckily for us, there's no need to write these exploits ourselves. This is because a key technique that the course, the PEN 200 course, which is behind the OSCP certification, one key technique that this course is trying to teach you is the ability to search and use already existing exploits. And so to this end, first you need to search for them, and then you need to understand how to use them. When it comes to searching, you can use various tools. For example, you can use the search exploit tool, which internally uses the exploitDB platform, which is also handled by offensive security, as an underlying database of well-known exploits. So like exploitDB is just a big ass archive of known exploits, and if you just write search exploit and then some string like WordPress version 3.2, you get back a series of results, and these could be your exploits. In general, you need to learn how to use search engines to enumerate the exploitable surface area of a given technology, searching for old CVEs, searching for GitHub repositories, and so on. So like, do not limit yourself to search exploit. Learn how to use this tool because it is very handy, it can be very useful, but do not limit yourself to search exploit. Always use multiple search engines such as Google, DuckDuckGo, and there are many others. And the idea is that you want to target vulnerabilities for the specific technology you are trying to attack, which means that first, before even understanding if that platform, if that technology is vulnerable, you need to understand first what kind of the name of the technology, the name of the platform, and secondly, the version that you are dealing with. Once you have this true information, then you can start searching for exploit related to that technology at that particular version, because this is really key. And of course, there is no general way to enumerate this information. It also depends on the specific technology. Sometimes it's easier, sometimes it's harder. It depends on what you're dealing with. And yeah, for the things that you need to search, like CVEs, also like GitHub repositories, sometimes they contain the code for exploiting vulnerabilities, and so it's really, really handy. In this search, an exploit could be anything. And this is a really important part. An exploit is not just a script that you can execute and that directly attacks the target. An exploit here, we have to open our mind a little bit, because for exploit here, I mean anything. Going from a simple nodes.txt detailing how to perform an LFI in a web application to a complex Python script that automatically executes that action. So if the action itself is not too difficult, maybe instead of having automated with Python, you can just have someone that tells you, look, you do this request, this HTTP request, and you get an LFI. So do not limit yourself to just code. Try to understand the meaning of everything that you find related to the technology you're trying to attack. After your enumeration, if you meet a specific complex piece of technology, be it a web app, a Windows service, or a weird Linux Elf binary, try to search information on the web to see if in the past it has been exploited by other security researchers. So the idea is, first you enumerate the target area, the attack area, and you find not only the version of the software, but the software themselves, like what kind of software do I have? What kind of implementation of the web server do I have? Do I have an Apache Tomcat or do I have an Nginx? Different software means different vulnerabilities. And this when you are outside. If you get inside and you have to do privilege escalation, well, if you are on Windows, you might as well enumerate the installed application and the currently active Windows services. And then if you find like a custom service, which you typically don't find in Windows, then you can search for that particular name on the internet using Google, DuckDuckGo, any search engine you prefer, with the keyword like exploit, vulnerabilities, CVEs, depending on what you need, and you might find something. Then try to understand what kind of exploits are useful to you among the ones you found and what kind simply do not matter. And this is another really important technique that you need to learn. It is not just about finding exploits. It is also about reasoning about them. What do I mean, reasoning about exploits? Well, the idea is that you're sort of playing like a game, like a chess game against the server. And in this game, you have to play by rules, the rules of technology. This means that, for example, if you're interacting with a web application and you want, of course, to get remote code execution, and then you find an exploit, and this exploit gives you remote code execution, but it requires you to be authenticated, then you cannot use directly that exploit because initially you are not authenticated. At that point, you might either try to find some credentials and authenticate yourself so that you can use the exploit, or you might find a different exploits to be authenticated, to become authenticated in an unauthorized way, like using another exploit. So you can chain exploits one after the other, and each exploit will give you a series of like things that of power over the server, and you need to be able to understand what kind of things you want, what kind of things you need to finish the machine, and what kind of things simply you do not care. For example, if you have an XSS and there are no clients to attack, there is no information to leak or something like that, then with a simple XSS, you're not going to do that much. So you need to understand how to reason about exploits, to understand what exploits are useful to you in that particular situation. And here I give some example. For example, if I'm trying to elevate my privileges from user to root, I do not need exploits that trigger a denial of service within a web application. When I search for such exploits, I might find them. I might find like CVE 2019 something denial of service or whatever, but I do not care about that because what I'm looking for is maybe local privilege escalation in related to the binaries that are installed in the target server. If I need other exploits that will let me elevate my privileges. This technique, the using a custom exploit technique, which I call a technique because it is a technique on its own. I mean, previously we talked about password cracking, which had to do with dealing with password. The technique using existing exploits actually has to do with understanding the place of each vulnerability, understanding exactly how to read them, how to reason about them, and also understanding how exploits are typically written, like for example in Python. This technique is all about performing a correct enumeration. While it may seem easy to just use an already written exploit, there's still a significant learning curve in understanding which exploit to pick among the many, what needs to change within the exploit to make it work on your specific target, and in general, when to give up using an exploit which seems to be the one, but that in practice it does not seem to work. So like, when maybe you reason about it, you might say, but it's so easy, you just use an exploit written by other people. Well, it is definitely not as hard as writing an exploit yourself, and that's for sure. But it still takes some work to understand, to reason about the context you are in with. Like, for example, an exploit might be perfect in the description. It might elevate your privileges or something like that. But then when you actually try to use it, it does not work. At that point, you need to have the awareness to give up on using an exploit which does not work and try for something else. Or, conversely, maybe initially an exploit does not work, but is actually the right one. It's just that you need to change a few variables within the exploit script. Maybe you need to change the root of the server, of the web server. Maybe you need to change the credentials that the script is using, or the port that the script is attacking, things like that. Or maybe the version has slightly changed, so maybe you need to drop some requests, add some more. I mean, typically when it comes to OSCP, you do not need to do many changes to the exploits already written, but you need to understand how to read them. And this means that in order to read the majority of exploits, some fluency with C and Python can help you a lot, although it is not required to be an expert in those languages. And when it comes to reading exploit related to OSCP, we do not need to be experts on C or Python, but we do need to know how to read such languages. Now, to give a practical understanding of what it means to read and to understand an exploit written by someone else, I prepare a small example with respect to a given CVE. So here we're talking about the CVE 2021 41773. And if we want to find details about the CVE, you can just go into any site and we can see the description, we can read the description, and it says, a flaw was found in a change made to path normalization in Apache HTTP server 2.4.49. So the idea of this vulnerability is that it could be exploited to obtain a path traversal, a directory traversal attack. So you could read files which were outside the root web server. So for example, you could read the /etc/passwd file. Now, to understand better this vulnerability, I found two things. One is a public exploit and the other is a Docker image which showcases this specific vulnerability. So here I have two links to mention and I will put them in the description. So the first one is an exploit for this vulnerability, which you might find if you just write, for example, path traversal RC Apache 2.4.49. So for example, you're doing an nmap and you find, oh look, there is this version of Apache. Let me see if it's vulnerable to an RC or something. And then you find this exploit. So this is an exploit written in Python, and we're gonna clone this. And I'm gonna put a link in the description here. So we're gonna do git clone, and we're gonna clone in this directory. That's it, good. The other thing that I prepared is actually a Docker image, so we're gonna use Docker to create a vulnerable scenario. So I'm gonna create a vulnerable Docker file, and here is the link to the Docker file. And to actually build a Docker file, here is the Docker file. This is pretty easy. You just copy the vulnerable configuration from a basic HTTP Apache server image. So you do docker build -t, then you give it the name CVE 2021 41773 dot. It already built. It's pretty easy, as I said. And then we can go and run it. Now to run the Docker, I do docker run, and then essentially I do docker, so like I do docker run -im-d, then I do the ports. Now the ports I'm gonna map 1337 to my host to the 8 internal of the Docker, and then I do CVE 2021 41773. And I think this should be it. So I launch the Docker, now the Docker is running, and if I do a curl to HTTP 127.170.1 to the port 1337, I get the it works page. And indeed, if we go with the browser to the IP address 1.7.0.0.1 to the port 1337, we are essentially attaching to the internal Docker. And if we, for example, have, I don't know, nmap, so we do nmap, and we do nmap and we do a scan to the port 1337 to the host 1.7.0.0.1, which is ourselves, we should get the specific version of Apache. And indeed, from this scan, what do we get? We get that in the port 1337 of the host 17001, which is our local host, we find Apache HTTPD 2.4.49. And if we just search for this version, just do a search and we search for this version and then exploit, we're gonna find our path traversal RC, this GitHub page. So at that point, we might be interested in just reading the code. So we have already cloned the code and we can read it. Now, as you can see, this is a Python script. So we have a bunch of things. For example, we have a requirements file. Now, in Python, requirements contain the libraries that we use while for executing the code itself. And so we have a bunch of knowledge, if we have it's better of course, to deal with Python code. In this case, I'm gonna read the main, and as you can see, we have the author, we have the coding, we have the Python code, we have the exploit. As you can see here, there's a lot of code, There are like almost 200 lines of code. It seems hard at first. However, if you actually know how to read Python, this becomes much easier. What is this script doing? So I'm gonna go fast through it because the point of this video is not to teach you Python. It's just to showcase the kind of skill you need to read an exploit. In this specific case, the exploit was written in Python, and the reason why I wanted to show it to you is because even though at first it seems like it's doing a lot of things, actually, in its essence, the exploit is pretty simple and you don't need all of this. So if you're able to extract the essence of the exploit, then you can just give it up and you can do it manually, or you can just use it the way you use it. So in terms of reading the exploit, here we're importing a bunch of libraries. In particular, there is the requests library, which is used to make HTTP requests, so like get or post. Then we go to the end, we have an exploit function which takes an URL as input. We have a test check headers function. We check headers for the vulnerable version of Apache, and then we have the main function. So the main function stamps a banner, and then it tries to collect the arguments needed for the exploit to work. And then you have this thing, which is actually called at the start. So at the start, when you call the script with Python, when you do Python main, when you call the script like that, essentially what gets executed is actually a clear to clear the text, and then the main function is executed. And then if we go to the main function, we print this banner, we sleep for like 3 seconds, we get the arguments, and we open a file. So he wants us to pass to the script a file, and this file will contain a bunch of URLs. So for each URL in the file, what do? We check if that URL is vulnerable, and if it is vulnerable, we exploit it. So the check vulnerability simply does a request, a head request, and it checks the header of the server. If the header contains the Apache version, then we are good. Otherwise, we are not good. And for example, if I can create a file, I say I create a file named urls.txt, and in this file, I'm just gonna write 1.7001.137, which is the endpoint vulnerable, and then I do Python 3 main, and then I do no module name term color, so I need to download this module, but I'm gonna create a Python environment. So here I'm gonna go a little bit fast just to showcase you how I would approach it. So first I create a Python virtual environment to store all the dependencies. Then I install all the dependencies with pip3 install using the file requirements. So here I'm installing everything. So this is the command pip3 install -r requirements.txt. Once I have the requirements, I can execute the script, the exploit. And this sleeps a little bit. And then it says error because I did not give it the URL file. Then I give it the URL files, and it sleeps a little bit and it does nothing. So at this point I might be wondering, like, what is happening? What is going on? Well, the idea essentially, I think, is that in this case, the exploits here never gets anything from this part. In the response, if I check the response.headers, if I just print the response.headers here, and I do it again, let's see what we get. We get nothing. We get nothing. Why do we get nothing? Maybe because we have to, for URL in file, as file, print URL. I think the problem is, okay, so here I print the URL. That's good. Check headers URL.strip. Okay, vulnerable URL. So I do this print URL. I'm printing the URL given to the check headers function to check what's okay. This is it, but wait. Okay, so the URL is correct, but then I do try. Let's try to print this exception. Print E. Print E. Let's try to print the exception that I'm getting. I think I'm getting an exception here. What is it, I wonder? No collection adapter were found for okay, because I've written the URL wrongly. I had to write HTTP. You see, this is something that you find just by debugging, just by running the code multiple times. So here I put HTTP, and then here we get, okay, target could be vulnerable, and boom, it stamps the etc passwd file. So what this showed us is that before we knew how it worked, it didn't work because I did not put the HTTP : // So this is one thing that we learn. But if we want to understand it even deeply, what we can do is essentially that this function could be totally removed if we know that the target is actually vulnerable. And finally, the exploit function is written in a way that we check different versions of Apache. So we have two types of attack, one for the version 2.4.50 and one for the version 2.4.49, which means that in our case, for example, we're going to hit the 2.4.49 because that's the version running on the server. Now for this version, there are two things that it does. And there is this first for loop, and then there is another for loop. If the first for loop brings out no vulnerability, then we perform the second. Otherwise, we just do the first. And in this first for loop, he prepares different types of payload depending on how deep the server is in the remote file system. So here, if we just print the payload 1, and we just print it the way it constructs it, we can see that it's gonna construct more folders going backwards more and more. We can just wait. And as we can see here, it stamps first with just one payload, then with 2, then with 3, then with 4. And this essentially encodes the act of going backwards in the directory. So 1 going backwards is not enough, 2 is not enough, 3 is not enough, 4 is enough. Because if we go backwards 4 times, then we can reach the etc passwd, because if we go backward 4 times, we can reach the root directory of the file system. And so essentially the idea is just this. Once we have this payload, we can just use it as a sort of like we have temp URL plus payload. So the actual payload that we use, this temp URL, we can print it afterwards. It's gonna be the payload that triggers the directory traversal. So we don't even need this complex script. We just need to understand the vulnerable payload. So the vulnerable payload is this one. So if we do just a curl with this vulnerable payload, we just do a curl and we get back the etc passwd. So the idea to write this, to understand this exploit essentially, was that it was not completely trivial, but the exploit made it harder than it actually was in reality. So when you read stuff like that, you might be scared because you might be like, oh my god, what is it doing? While in reality, it's doing something very simple, which could be encoded, could be written in a seemingly complex exploit, which at the end of the day could be exploited with a simple GET request with a bunch of encoded characters that the path normalization does not take into account, which allows you to actually exploit the target. So in this case, we can exploit it to read the /etc/passwd. For example, in the target machine, if there was this vulnerability, we would try to find, of course, like an RSA SSH private key, for example, in the home user of, I don't know, if we have other user, we can see from the etc passwd, and then we can check their home directories. So this is the idea when it comes to reading such exploits. We do not need to be afraid of delving into the code, of understanding the main structure, but once again, when it comes to OSCP, the difficulty is not too much, it's not too complex, so don't be scared, just read the code. It's all about the code. It could be Python code, it could be C code. Typically, it's either C or Python, so you don't need to look for more stuff like Ruby and Perl. You don't need to look at those. Just focus your effort on reading basic Python code and C code. For example, in this script, the main deal is the request library, which allows you to perform request. So here I say, for example, where do I put the request? Well, here I say request urllib request.request or URL open. So I think URL open is from URL lib request. So like, just understand how Python, the most important Python libraries, for example, to perform HTTP request, which is the library request or the internal library URL lib request. Once you understand that, all this code is essentially doing a bunch of HTTP requests, and everything else just makes it seem more daunting, but in its essence, it's very simple. And that's the idea for most of the exploits you will find in OSCP. Do not be scared by the nature of the exploit. Try to understand what they do. Try to see why they are not working. In our case, it was not working because we did not put this HTTP, but the script was written in such a way that it did not tell us. We had to understand the code and we had to add a print here, because if I don't add the print here and I just add the pass, okay, and then here I remove this protocol and then I execute the exploit, it's not gonna print anything. So I might think it does not work, while in actuality it is the right exploit. It's just that the way it was written did not take into account the fact that I could write the URL in a different way. But then I can add some code. I can, for example, see, look, here there is an exception, but I'm not printing anything. I wonder what it is. I add a print statement, I execute again the script, and I get like, oh look, no connection of apples. What is this error? And if you know some Python, this error is because the library tries to connect and it does not know the protocol to speak. So you add this layer, and once again, you execute Python, and this time it's gonna work because it's gonna know the protocol, it's gonna use HTTP, and everything else is gonna work. And then we have a working exploit. And with this, I conclude the video on using existing exploits. I hope this example, the CV 2021 41773, was a useful and practical example. Of course, there are many other CVEs, but I cannot make a video for each one of them. I hope it was still interesting and enjoyable. If you have any feedback, please leave it in the comments. Please subscribe if you're interested in my content, and in the next video we will talk about port forwarding and pivoting, which is an extremely important technique that you must know if you want to do OSCP.